Greetings, fellow grade 11s. It's Mr. Hlajai here, and welcome to Back to Basics. So what we are doing now, basically, we are doing our analytical geometry. Now we are using a past paper in order for us to try and understand in terms of how do we tackle such questions, right? Now let's start. Now, firstly, I want us to look at this particular diagram here. What is it that we are given here? Basically, we are given that we are having what? We are having your triangle KLN, whereby you are having the equation of KL, which is equals to y is equals to 5x plus 9, while Kn is an equation which is equals to 5y plus x minus 19 is equals to 0, right? Now, the first question is, they want us to show that the coordinates of K is going to be equal to what? It is going to be equal to -1 and 4. Now, how can we go about in showing these particular equations, right? So now, remember we already have these two equations. We have y is equals to 5x plus 9. We are also having what? We are also having 5y plus x minus what? Minus 19, which is equals to 0, right? So we can literally just make this to be our equation number 1, and you let this to be our equation number 2, right? Then you're going to substitute equation 1 into equation 2. Why are we doing that? Remember, this K, it is the point of contact from these two equations, from this equation here and from also this equation here altogether. So which means now whenever you're looking for point of contact, you equate both of these particular equations, right? So now we are going to say this is same as 5 into this is going to be 5x plus 9 plus close bracket plus x minus 19 is equals to 0. Then this is going to be 25x, and then this is going to be 25 plus, then what is it that you're going to do now? 5 multiplied by 4. This is going to be 45 if I'm not mistaken, right? Yes, this is going to be your what? 45 plus x minus what? Minus 19 is equals to what? Is equals to, this is equals to 0. Then now we are going to group our like terms. Now x plus 25 is going to give you 26, right? So you're having 26x, then you're having here 45 subtract 19, which is same as what? 26. So which means this is going to be equals to also negative 26 when you take this side. So you are dividing by 26 here, divide by 26 here. So the value of your x that you are going to find, it is going to be equal to your -1 altogether. And as soon as you are done that, you are done with that, then you are going to substitute what? Substitute your x into, right, into equation number 1. So which means this is going to be y is equals to 5 into -1 plus 9. And can you see that this is -5, and then -5 plus 4, this is going to be same as what? Positive 4, which means now the coordinates of your k, your coordinate of your k is going to be same as -1 and also your 4. All right, again. So it's going to be -1 and also your 4. Now, from there, they want us to show that the KL is perpendicular to KN, right? So the best thing that we use, let's just remove this one, right? The best thing that we use in order to show what? In order to show that what is going to be. Now, whenever you want to prove a perpendicular, what you are doing here, basically, you need to just find out what is going to be the gradient of both lines, right? So, which means, for an example, already we know this is equal to 5x plus 9, which means the gradient here is 5, right? Now, on this one, the one of 5y plus x minus 19, what is going to be this one? Is equal to 0. Let's say we are making y to be the subject of the formula. Can you see that this is going to be same as your 5y is equals to -x. This is same as -x plus 19. Then you divide by what? Divide by 5, divide by 5. Are you seeing that, right? Divide by 5 so that these and these cancel, right? So which means your y is going to be same as -1 over 5x plus 19 over 5. And now from here, you are then going to say, you are going to take both of these gradients, right? You are going to take the gradient of -1 over 5 and also 5 and multiply them both, right? So which means this is going to be, you what? You are going to say the gradient of what? The gradient of our line KL multiplied by the gradient of what? Of Kn, right? I want to get, and in terms of what is it that you're going to get, this is same as 5 multiplied by -1/5. The answer that you're going to get, it's -1. So as soon as you are getting that the answer is -1, therefore you're going to conclude that your KL is perpendicular to Kn. The reason being, it's because when you multiply the gradient of KL and the gradient of Kn, the answer that you are getting is -1. Out again. So basically, this is how you prove this particular question. Out again. And then now, which means now you are also, as soon as you are proving that, you are also saying that your angle of LKM, basically you are saying LKM is equals to 90 degrees. So that's what we are saying, right? So which means basically this angle here, it's 90 degrees, right? Then now from here, what is it that you are going to do now from here? Let's just make up our space here so that we can see in terms of what else now can we do from here. Now, let's look at the next question in terms of what is it that you have there, right? Now, in the next question, what is it that they are looking for basically, right? In the next question, we are saying now, hence, determine the area of KNL, right? KNL, right? So now, how can you determine that particular area, right? So in order for you to determine the area, remember the area of right-angled triangle. Remember this one, right? You are going to have what? Remember for your area, it's half base multiplied by height, right? Half base multiplied by height. And now that you're having this, right? So what is it that you can do now from here? Now you can simply calculate what is going to be the length of Kn and what is going to be the length of Lk, right? So which means this is going to be your height and this is going to be your what? Your base here, your height here, right? So let's look at the distance of Kn first, right? So what is going to be your distance of Kn? Obviously, for distance, use the distance formula. X2 subtract x1. Now this is squared plus this is y2 subtract y1 squared, and this is going to be equals to what is going to be your x2. Now from here, what else then now are you going to have from here? Let's see. This is going to be same as your -1. Let's say we are saying -1. Subtract your 4 all squared plus this is 4 subtract your 3 all squared, right? You are going to find out that your Kn is basically going to be root of 26, right? Now let's look at this one now, right? Let's say we are looking for your Kn now. Out again. Let's say you are looking for your Kn, right? So basically this was our Kn, right? Now let's say we are looking for your Kl, right? Now your KL is going to be equal to what? Remember, we already know our distance formula. So this is going to be same as -1 subtract -2 all squared plus this is going to be 4 subtract -1 all squared. Then now what is going to be the distance? This is going to be same as 26. And now from here, as soon as you're having your 26, then which means now both of these are equal, right? So you can literally just say our length here, our length, or rather our area is going to have the base is root 26. The height is root 26. Can you see that? And then now you're going to find out what is going to be the answer that you're getting here, right? So that's going to be same as 13 units squared, right? That's going to be a 13 units squared. So basically, that's what you are going to do for this particular question here for your 4.3, right? Remember, you just use your area formula for your triangle, which is half base multiplied by height, and then you calculate the length of your base and height, and then you substitute into the formula. Again, it is that simple. Now let's look at now the following question, right? Let's just make up our space here. Let's look at the following question in terms of what else then now are you having, right? Now in the next question, we are saying now from here, We are saying now determine the equation of the perpendicular bisector of what? Of Ln. Determine the equation of the perpendicular bisector of what? Of Ln, right? Now, what bisects Ln basically, which means they are saying, now let's say for an example, you draw a line from what? You draw a line from here, right? You draw a line from here, okay, and then now this line is going to bisect this, right? Can you see? That's what they mean when they say a perpendicular bisect. Now they want you to do what? They want you to find out what is going to be the equation of the perpendicular bisect, right? Now before you can even find out the equation of the perpendicular bisect, you firstly need to find out what are going to be the two coordinates here, right? Now how can you find the coordinates? Can you see that here? What you're looking for your midpoint, right? We can just let this to be our midpoint M. Okay, so which means now we are going to apply your midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. And what is going to be this? The x1 here, can you see this is same as -2 plus 4 over 2. The other one is going to be same as what? -1 plus 3 over 2. And now what is it that you're going to get? You're going to get the midpoint, which is 1:1, right? So which means the coordinates of M here is going to be 1:1. And now that we found out what is going to be the coordinates of 1:1, right? Now what else now can we do? What else now can we do? Now, I know I just made an assumption that this line will probably be coming from K, right? Which may not be necessarily the case. Okay. So, but I was just making you aware that when they say a perpendicular bisect, it's basically a line. It can be coming from any of these margins, right? But it is cutting your line LN into two equal halves, right? That's what I wanted to clarify. So now what is it that we are going to need now after that? We are going to be in need of the gradient of that line so that we can find out the equation of that line, right? Now, already we have the point. How can you find the gradient? Now, in order for us to find the gradient, firstly, now, since this is perpendicular, so you know that the gradient, you can say the gradient of the what? The gradient of what? Your gradient of NL firstly. If you can find out what is the gradient of NL, then since this is perpendicular, then you can just say the both, when you multiply both gradient is equal to -1, then you can get the gradient of the line that is a perpendicular bisector. Okay, so now we are going to say, what is the gradient of my NL? This is going to be same as y2 subtract y1 over x2 subtract x1. Now, what is going to be your y2 here? Right? So you can just take 3 subtract what? 3 subtract -1 divide by 4 subtract -2. And what else then now are you going to have? Now from here, this is going to be same as what? 2 over 3. Now the 2 over 3, it is the gradient of this particular line here, your line L and L, right? So now what else then now can you do? Now you know that the gradient of NL multiplied by the gradient of the line at M is equal to -1, right? Because of what? Because they said these lines are perpendicular bisectors. Can you see that? Now, which means now basically, therefore you can say the gradient of the line at M is going to be same as what? Can you see that it's going to be same as, remember when you substitute 2 over 3 here, what is it that you're going to get? The gradient you're going to get this as -3 over 2, which is the gradient of the line here at M, right? And then now you can literally now substitute because you have the coordinate. You say y is equal to mx plus c, right? And now what is the gradient? The gradient you already have that. The gradient of this particular line is what? The gradient of this line. Remember now we are looking for the gradient of that particular line. So you are going to say the gradient is going to be same as y is equal to mx plus c. And now, in order for you to find that line, remember we've already found out that the gradient was what? Was 2 over 3. Then now we are going to rectify that, which means you are going to say your y is going to be equal to -3 over 2 what? -3 over 2x over 2x plus c. Then you substitute the point 1:1, right? When you substitute the point 1:1, this is 1 is equals to -3 over 2 into 1. then plus c. Then when you take this one this side, it's going to be 1 plus 3 over 2 is equals to your c. Therefore, your coordinates of your c, right? The c that you are going to find here, it's going to be same as 5 over 2 if I'm not mistaken, right? Now, for 4.5, now in order for us to find out what is going to be the coordinate of P, they are saying if L, N, and P are collinear, find Y. Now, this is simple. Firstly, remember from collinear, we know that the gradient is the same, right? So, which means now you can say the gradient of what? The gradient of your what? Of your NL, right? The gradient of your NL is going to be equals to what? Remember, it was the gradient of your NL is 2 over 3. Now, what is it that you can do now? You can say now from here, you can take n of these coordinates. You can take the coordinates of n for an example, and then the coordinate of the p. We are not sure where is the p. Where do we find our p? Okay, but we know that our x is somewhere at 7, right? So which means our x is somewhere here at 7. So now we are going to say, when you are saying the gradient of NL, you are going to say, remember the gradient is given by 1, what y2 over y2 subtract y1 over x2 subtract x1. So this is going to be 2 over 3 is equals to, now let's say we are using the coordinate of p, which is what, which is same as 7 is 2y, right? Now what is it that you're going to do now from here? This is going to be same as y subtract 3 divide by what? Divide by 7 subtract your 4. Can you see that, right? Now, what is this going to be? This is same as 2 over 3 multiplied by 7, subtract your 4. This is same as what? 3. Plus what? This is going to be is equals to y subtract 3. Then this is going to be same as 2 is equals to y subtract 3. Then you transpose here. Then your y is going to be same as 5. Can you see that, right? So basically, the coordinate of your p of your y here, it's going to be same as 5. Okay. Hopefully now this makes sense to you now. Let's move swiftly along to the next question. All right. Now, in the next question, what else then now are you going to have? Now, in the next question, they want us to determine the coordinates of Q if KLN, KLQN is a parallelogram, right? Now, they are saying if, let's say, you are dragging this, let's say, this one somewhere here, you are also dragging this shape here. Now, they want this to be your parallelogram, right? Now, what is it that we can do now from here? Right now, if this is your parallelogram, what is it that you already know, or one thing that you can take from your parallelogram? Remember, we know that the parallelogram, the opposite sides are equal, and what the opposite sides are equal and opposite sides are parallel, and the diagonal of your parallelogram, they bisect each other, right? So if, for an example, we are looking at the coordinates here, which is going to be your coordinate of Q. Now you can literally just use what you can use this this equation k negative 1 4 and m and also q. Remember, we can just take this straight line. You can just take the straight line where you are having your q, where you are having your m, and where you are having your k. All right. And now what is this going to be? This is same as negative 1 and 4. This is same as what? 1 is to 1. And then this is going to be same as what? This is going to be same as your what? Your x and your y, because you don't know this, right? But you know that your m is the midpoint. So you can literally just plug this into your midpoint formula, right? But you can break down the midpoint formula and say, look, my x of m is going to be equal to the x of k plus the x of q over 2. And then this is going to be also the y of what? The y of m is going to be the x of, or rather the y of k plus the y of what? Of q over what? Over 2. Basically, this is the midpoint formula, but I've just broken it down so that you can see it, right? Now, what is going to be the midpoint? Remember, this was 1 is equals to, and now the other one was going to be the x of what? The x of your k, which is negative 1 plus what? Plus x of your q over 2. Then when you transpose this side, what is it that you're going to get now? Can you see this is 2 is equals to negative 1 plus x of q. Then when you transpose this, your x of your q is going to be equals to 3. Now, when we make up our space for this other one, now, Now, for an example, what is it that you're going to have here? Your x or your y of your m. Your y of your m, what is that you're going to have? This is same as what your 1 is equals to what is your y of your k, for an example, same as 4 plus y of your q over what? Over 2. This is same as 2 is equals to 4 plus y of your q. Then when you take this one this side, can you see that this is same as negative? Negative 2 is equals to y of your q, right? So basically your coordinate of your q is same as 3 and what? And negative 2, right? So it is basically that simple for us to, to do this particular question. Now let's move swiftly along to the next question. All right. Now that we have our point Q, now we can simply just move to the next question. Now the next question, they say explain what geometric reason KLN is a square. Why KLN is your what? Is your square, right? So this is almost simple, right? Now already we know that this is going to be what? I want you to have an idea. Remember, we know that this is what the coordinate of here, it's given by 3 and negative 2. Now, what were our findings? Our ln was root what? Was root 26. And our kn was root 26. And also, we found out that our LKN, it is 90 degrees, right? And we already know that the opposite sides of a parallelogram are equal, right? And but this one, which means this, it's going to make this to be root 26. But now, because this must be equal to this must be root 26. Can you see that? Root 26. So you can see that all of the sides are actually equal, right? And the opposite sides are also going to be equal, because if this is 90 degrees, this is going to be 90. And now this is also going to be equal to 90, and this is equal to 9. So therefore, it satisfies the characteristics of being a square. Once again, so but we are not allowed to just conclude on that. So you must start now afresh. You say K is equal to 90 degrees. Altogether, this one is proven. Remember, we've already proven that our K is equal to 90 degrees, right? And you can also say, look, our KL is equals to what? Our KL is equals to KN, which is equals to root 26. Remember, this was also proven, right? But when was this proven? It was actually proven in 4.2. Right? And then now you are going to say, look, our K L Q N is a square. And what is the reason behind us saying this is a square, right? We are saying all parallelogram with an interior angles of equals to 90 degrees and adjacent sides are equal, right? So we are saying the interior angles, the interior angles are equals to 90 degrees, and what? And the adjacent sides are what? Are equal altogether. So then now from here you can just conclude that this is going to be a square altogether. Hopefully all of these make sense to you now, and you're in a position to answer all these types of questions as they come. Thank you very much.